Welcome to my channel. Today we are going to see a session on causal and non-causal signals. So this can be asked for 2 marks under signals and system. So in order to know about causal and non-causal systems, let us find the condition for a system for a signal to be causal. So for the condition for a causal signal is, for a CT signal x of t must be equal to 0 for t less than 0. Then if it is not equal to 0, if it is having any value for t less than 0, then the signal is said to be non-causal. So for a given signal, it is 0 for all negative time values. So t less than 0 means -1, -2 till minus infinity. So 0 for all negative times. Now we will see some of the problems based on causal and non-causal signals. So the question will be like this: determine whether the signal is causal or non-causal. So in order to do it, first we have to the problems will be in terms of 2 marks, either 1 or 2, or it depends on the questionnaire. So first question here is e power 3t into u of t. So you must know the condition. Already we have seen in standard type of signals what is u of t. U of t is a unit step signal where it gives a value of 1 for t greater than 0 and 0 for t less than 0. So our condition here is it should be 0 for t less than 0. So when substituting, instead of this condition u of t as 0, the value for the given signal is 0. Hence the given signal is causal signal. Let us find out what is the second sum. So e power minus 3t into u of minus t, you have to find whether the signal is causal or non-causal. So the condition for u of minus t you have to find. So what is u of minus t means? It takes a value of 1 for negative values of t. So 0 otherwise. So what is our condition here? It is equal to 1 for t less than 0. So it does not satisfy the condition of causal where it is to be 0 for t less than 0. So when you substitute, instead of this u of minus t, it becomes the value of e power minus 3t itself, which is not equal to 0. Hence the signal is non-causal. So this is how you have to write for each and every 2 marks. Given signal is non-causal. Next one is e power minus 2t u of t minus 1. So u of t minus 1 you have to find. So it is in the negative, so you have to shift the signal by 1 times to the right. So the signal becomes value of 1 for t greater than 1. That is, this is a unit signal, step signal, which is having a shifting of t minus 1. So the condition here is for t less than it will be 1 for t less than 0. So when you substitute the condition from the figure itself, you can see for t less than 0 it is 0. So when you multiply it for this condition, it is equal to 0. Hence the signal is said to be causal signal. So again one more example, 1 by 2 whole power n u of n plus 3. So u of n plus 3 is nothing but which is to be shifted 3 times to the negative side. So here negative side means it becomes it can be drawn like this, for 0 to 1, 2, 3, 4, 5 to the right, and 0, minus 1, minus 2, minus 3, minus 4, minus 5 to the left, and unit step signal where it has the amplitude value of 1. For n plus 3, the value will be drawn like this, blue shaded signal, where the value will be equal to 1 for n is less than minus 3. So here you could see here, instead in order to show visually, I have drawn these samples like this, but for sample signals you have to draw in terms of samples only. That is, you have to draw with the header with the tail end. So here the value is 1. So you could see here for n less than 0, the value is 1 here. So here you could see it is not equivalent to 0 value for n less than 0. So it is having some value till the value of minus 3. Hence it is not equal to 0, which implies the signal, given signal is non-causal signal. Hence you can write like this, hence the signal is non-causal. Next one, 1 by 2 whole power n, u of n minus 3 again. So here also just identify the unit step signal functionality where n minus 3 is given as 1 for n greater than 3. So this can be shifted to the right side. Here it is minus 3 value, so it should be shifted to the positive end value of 3. So you could see here from the diagram itself, if you have drawn for one value, the unit step signal in terms of discrete, it should be drawn as samples. In order to show you, I am drawing it in a straight line. That is, I am showing it in CT, but you should draw in samples. So from the given figure itself, you can identify it is having the value of 0 for n less than 3. So when it is multiplied by 1, the value will be equivalent to 0. That is, for the given signal u of n minus 3 value, it is 0. So hence the condition for stability is, condition for causality is satisfied. Hence the given signal is causal. So our next example you could see here for a given signal. That is, let us take for sixth one problem. Again a simple problem. X of n is equal to u of n plus 3 minus u of n minus 4. So u of n plus 3 is nothing but which is having a, from this problem you could see directly from previous explanations or examples, you could see whether it is to be having values at the negative value or towards positive values. So it has both positive and negative values. So for 2 marks you could write only this. Since it has both positive and negative values, the signal is said to be non-causal because it should have only the 0 value for the given condition of t or n less than 0. Next example here is sinc functionality of t. So what is sinc function is nothing but which is drawn like this. It is not exactly a sine wave, but it is a bell-shaped wave where the one type of signal, one signal has a peak value with the biggest signal content for the 0 level. So where the sinc function is used is because of the to avoid the interference, we go for this sinc functionality, which is the basic concept in nowadays OFDM technologies. So I have shown this in green, blue and red color, where you could see here the peak of one signal will be the 0 of next signal. So in that way you could see here the maximum signal is contained in this big signal value, and it could see here from the figure itself it has both positive and negative values. And since the signal is containing both positive and negative values, we can conclude that the signal is a causal signal, because non-causal signal, it is a non-causal signal where it has a value of positive and negative values. So for this exercise problem, you please do it yourself. For example, sin t into u of t. Second one, e power minus 2t into u of t minus 2. Third one, cos t into u of t. And we could see here for each of this, the answer will be like this. Please check it out. It will be, this is the example for causal. Let me show you same thing with examples of non-causal. So from the given itself we could identify. So from this you could see here u of t, u of minus t, all these terms. So whenever u of t is coming or u of t minus value is coming, you could say the signal is causal. Whenever the signal has unit value of u of t plus 3 in terms of t shifted with plus term, that is t plus 3 or t plus 2, you could say the signal is non-causal. So similarly, some problems like non-causal signals is also given. So please do it yourself with these following steps so that you get practiced to write the answers. So these are from 5th, 6th to some 8th problem. Non-causal signals examples is given. So I have given the answers directly, but please identify how this signal is said to be non-causal, because it is having a shift of t plus 3. This is having the value of t minus of 3. It's a minus of t. So minus of t is nothing but where the signal is contained within minus t signal. So graph you identify minus t, minus infinity to plus infinity. So it comes under the left side. Next, these are the hints as I have explained earlier. For t greater than or equal to 0, the signal is said to be non-causal. For t less than 0, the signal is said to be causal. So based on that condition, so please identify with respect to the graph where the graph is shown with t less than 0 and t greater than 0. So it is 0 for all the negative times, whereas negative times means which comes with plus 3. So it has a shift towards minus negative side. So for negative times, we can say it is having the value of t plus 3, t plus 2, something like that. And minus t of value also contains the non-causal signal. So this is how the non-causal signals are identified. And when coming to causal, it, as I explained earlier, it is having the value of shifting towards the right side. So u of t minus 2, u of t minus 3, etc. all comes under causal signals. So when sometimes you have the positive and negative values which we get confused, we should conclude it as a non-causal signals. So for non-causal signals, it is having the both positive and negative values. So this is how the problems are asked in causal and non-causal signals. So hope you understood whatever is taught here. So please share with your friends, and you please clarify all these doubts then and there, so that it will be easier for you to gain good marks in your examinations. So please